All right, this is a pretty huge topic, and I just want to be very clear that it makes me a tired potato. Rational numbers is a huge vocabulary piece, but then there's all the operations with rational numbers. The whole thing that this focuses on currently is just basically the vocabulary. If you're unable to identify rational numbers, then you're unable to do the operations with them. It's not necessarily true, but it makes it sound better. So rational numbers, here's what you got to know. You got to learn this whole new language. This all these symbols, you have to learn all of these things and what they mean. I mean, I don't even know what they mean. I'm just kidding. Oh, there it is. How about that? 82D, order a set of real numbers arising from mathematical and real world context. Well, first off, what we need to do is identify real numbers. What is and isn't uh, falling in the category of real numbers. And you can see that there's nested circles here, a circle within a circle, and then there's outside of their irrational numbers. They're irrational, they don't make any sense, and that's exactly why they're out there by themselves. But they're still real numbers. And yes, there is a thing called imaginary numbers. Uh, we're not going there. We're going with real first. Let's start with real. I feel like everything's pretty unreal lately. So the vocabulary. What you're going to do is you're going to start with natural numbers and you're going to work your way up. You're going to have no problem differentiating between natural and whole numbers. Uh, just know that irrational is going to fit outside of everything that you're doing. You're going to be a little discouraged probably during this because you're going to sit there and go like, oh my gosh, there's almost no difference between these. The differences are subtle. And that's why we're going over definitions first. Because if you don't know what's happening, you're going to get lost real quick. So let's just talk about natural versus whole numbers first. All right. So first off, we got El Natural number guy. Numbers 1, 2, 3, 4, etc. And you can see he's trying hard. Okay. He's really working at it. Versus the whole thing number guy, slanty face. Oh, that includes 0, 1, 2, 3, 4. So I'm just gonna let you stare at those for a moment. I'll highlight them because I can do that. And then I want you to try and determine the difference in what you see. And if you're sitting there going like, bro, are you serious? I'm going like, yeah, I am. And then you're like, but like, you got to be kidding me. And I'm saying, no, I told you before we did this that natural and whole are like almost the same thing. There's subtle differences. I think you spotted it. There's 3 dots over here and 4 dots over here. I'm kidding. It's the 0. Uh, a whole number will include 0. So this does not have fractions. This does not have decimals. It doesn't have any weird symbols. They are normal numbers. Natural numbers are the numbers that you learn to count by when you were a little kid. Like you didn't start with 0. You learned 0, but you're able to go, I see 1 dinosaur, 2 dinosaurs, 3 dinosaurs. And then whenever you got to whole numbers, that's when you learn the concept of 0, and you're able to take 0 away from something or add to get 0 or subtract 3 away from 3 and end up with 0. So that was a whole new concept. Natural numbers, baby numbers. Think of them that way. Whole numbers include 0. So think of integers as all whole numbers. Yes, including 0. So we got natural numbers, your baby numbers, 1, 2, 3, 4. Then we have whole numbers, which are 1, 2, 3, 4, including 0. And then you have integers, which are the same things as whole numbers, but their opposites are included. Opposites would be negative. So any whole number you could think of, like so you say 45, and its opposite, negative 45, are both integers. 0 is considered a neutral number, which is like an argument that could be made between really smart people that are above our pay grade, that whole numbers should not include 0, but for your education purposes, they do. Integers, 0 is the splitting point between positive and negative, thus making it neutral. Again, we've gone through 3 words so far, and we have no fractions or decimals. So it's like, are you serious? And it's like, yes, I'm serious. So whenever we get to this next slide, I'm going to have a number, and I'm just going to ask you to really quiz yourself on what you think it is. Your options will be the following: natural, whole, integers, and then we have rational. Rational numbers are the biggest category that fit underneath real numbers. What's rational? So rational has the word ratio in it, and that's not the highlighter. Rational has the word ratio in it. Ratios are when you have a comparison of two things. For example, 2/3, and that's a fraction. So now we're including fractions and decimals. So if we want to talk about rational numbers, we could talk about anything that has a fraction or a decimal. All right? So natural numbers, your baby numbers, 1, 2, 3. Whole numbers, throw in a 0. And then integers, everything that a whole number is plus its opposite. So 5, -5. And then whenever you throw in fractions and decimals, you get rational numbers. Always keep in mind you're looking at that word ratio. That's how you compare something. And this is set as 6/10, so that can be written as a ratio, which makes it a rational number. So there's a 5 there. There's a 5 just sitting there, and you're gonna think I'm David Blaine or David Copperfield. I don't even know if you know who magicians are anymore, but I'm gonna test your might. This is a 5. You can see that. I'm not insulting your intelligence. I know. I hope it's a 5. And I'm going to either ask you, and you're going to watch this, and you're going to go, natural, or it's a whole number, it's an integer, I could swear it's rational. Those are your 4 options, okay, right here. So whatever I do to this 5, I want you to tell me if it's natural, whole, integers, or rational, okay? Could be more than one, and then you're sitting there going like, oh geez, mind explosion. All right, here we go, enough talking. 0.5, what do you think? Well, you got to go through it. Let's see. It's not a baby number because that's not 1, 2, 3, 4, 5. It's 0.5. So it's not a whole number because it's a decimal, and it's not an integer because it's not a whole number or its opposite. So it's got to be just a rational number. I'm just going to put rat number. For some reason, these numbers like cheese. I'll never figure it out. That's not good. That's better. All right, so I'm going to modify this 5. -5, what do you think? Always start with the most basic. Is it a baby number that you learned to count by? Dude, if you were a baby and you started learning to count with negatives, you're on the next level, and like, I don't even know why you're listening to me. So whole, is it all the baby numbers plus 0? Does that fit in? Nope. Is it an integer? Yeah. Okay, cool, because its opposite would be 5, and that's a whole number. So we know that whole numbers and their opposites would be integers. So we know it's an integer. So is it a rational number? Could it be written as a fraction? Yes, it can. 5 divided by 1, still 5. -5 divided by 1 is still -5. So we have an integer and a rational number. And keep in mind that these things are nested under rational numbers. So if it's one of these or all of these, it's definitely a rational number. The only other option would be irrational number, which it is not. We'll get into that not this time. Okay, and let's go with, what do you think? Natural, whole, integer, or rational? Okay, so this is going to be a rational number. Rat number is cheesy because it's not natural, it's not a whole, it's not an integer because it's not a whole number with its opposite and or its opposite, but it can be written with something that has a fraction or a decimal. Bam. All right, a couple more of these. 4.5, what do you think? Natural, whole, integer, rational? Well, it's not natural because it's got a fraction or a decimal. It's not whole because it's got a fraction or a decimal. It's not an integer because it's got a fraction or a decimal, so it's a rational number. Okay? So these are just demos. These are just demos. That's all. And let's just go with 5. What do you think? Natural, whole, integer, rational? Okay. So is it a baby number? Could you count by it? 1, 2, 3, 4, 5? Check. It's a baby number. Natural. Is it a whole number? Is it a baby number and includes 0? So 0, 1, 2, 3, 4, 5. Yep. It's a whole number. Is it an integer? So is it a whole number and or its opposite? Okay, so 5, its opposite would be -5, but this is 5. So that still makes it an integer. All positive and negative whole numbers. So we have a natural whole integer, and guess what that automatically makes it? A rat number also. So the reason I showed the diagram at the beginning is because of this situation right here. Something can be natural, whole, an integer, and a rational number all at the same time. And don't forget, these are all nested under the real number system. So this is a lot of information to take in, and this is vocabulary that's going to be constantly reviewed. But the thing that's coming up next is an assignment. What I need to know is think of it like a pre-quiz, except I'm not grading you and there's absolutely zero pressure. There's no consequences to getting these wrong other than we have a conversation about it. These links up at the top are going to be a good way for you to practice. Some of them are better than others, and I have instructions play until it stops because unless you want to create an account, it's just there to order some different types of rational numbers. Classifying numbers is a really good one. I like that one a lot to practice the vocabulary. And then the last link, just try and get up to 200 points. And let me know if you did. So I want you to go into this assignment not with any type of frustration or reservation or getting upset about anything. There's nothing writing on this. This is only here to help. So it would be entirely more frustrating for you to be in class and not know this and then try and figure it out. So what we're going to do is we're going to try and figure it out, and then you're going to go into class and know how to do it. So that should feel real nice whenever you go into class and you're not lost. Please let me know if you have any questions at any time, and I will schedule something with you where we can meet virtually. All right, good luck.